Hello students, it's Miss Wink here. I'm giving to you your next lesson in this new unit. This lesson is specifically for 8th grade. So again, 8th grade, so if you're a 7th grader, this is not the lesson you should be listening to, okay? 8th grade, we just finished up your Unit 7. Unit 8 is very short. Like I said, there's only 2 lessons to it. There's 9.1 and 9.2, okay? This unit, I'm really sad that I'm not actually going to be able to do it with you. I really like talking about scatter plots, okay? Because it comes down to a lot of data and data collecting. So your 2 different icons here for this one is I can construct and interpret scatter plots, okay? And then I can describe patterns in scatter plots. We're skipping warm up as we have been before here. So let's go ahead and talk about what our essential question is for the day. So how can you construct and interpret a scatter plot? So we really first need to know what is a scatter plot. How do we construct it or build it? And how do we interpret? Remember, your interpreting means what does this really mean in the context of the data that I'm giving, okay? At any point during this video, you feel free to pause it, stop it, rewind it. That's up to you, given on if you're processing it right or if you need a little more time to write down notes. You can do that as well. All right, so here is our definition of what is a scatter plot. A scatter plot is a graph that shows the relationship between 2 data sets. The 2 sets of data are graphed as ordered pairs in a coordinate plane. Okay, so you're talking about 2 different sets of data. Okay, maybe you are looking at the temperatures and the time of the day. What happens to the temperature as the time of the day continues on? Okay, so you're thinking about your coordinate plane. Usually your scatter plots are just in that first quadrant. Okay, so I've got something that looks kind of like this. You're going to plot the points. Now, it's not like all the other graphs that we have been doing where there's a clear line and it says, okay, here's your slope, here's your y-intercept. We take the 2 sets of data and you just use the ordered pairs to graph them. So maybe you have a point that's here or here and here and here. Okay, maybe here, 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 here. Okay, this could be what your scatter plot looks like. Okay, so it's not going to have a very distinct straight line. They're not all going to match up, and they're not going to be able to just use a ruler to continue on with the line. You need to make sure you are reading the directions and putting in every single ordered pair. Okay. So let's take a look at our first example here. Okay, I'm going to kind of move things around, best fit kind of, so that we can see some of these things as well. So here is your example. It says the scatter plot shows the amount of fat in grams and the number of calories in 12 restaurant sandwiches. So again, it's taking 2 sets of data. So in this case, you're looking at the amount of fat in grams and you're looking at the calories as well. Okay, and here's the part that you're really measuring. You're looking at 12 different restaurant sandwiches. So this 12 means you're going to have 12 different data spots. So if you want to double check, you should have 12 dots here, okay? 1 for each sandwich. So they're comparing the amount of fat in that sandwich as well as the amount of calories that's in the sandwich. So we have a few different kinds of questions here to go through, but let's talk about this graph here first so you can understand it. The big important thing about your scatter plots is that everything needs to be labeled, okay? You're going to notice that there is a label for the graph. They're going to tell you what is it measuring. It's measuring the restaurant sandwiches. So just like I was telling you, you're taking those 12 restaurant sandwiches. Then each part of this, so the X and the Y, are also labeled. So in this case, this side is telling you about the calories, and this side tells you about the fat and the grams. Now, I believe I've talked to you about this part of the graph here before. But they're going from the calories and they want to jump all the way from 0 to 300. So you can just put a little squiggle line in there so that you don't have to count up, okay, I want to go 100, 102, because those aren't data points that we really need. So they're just kind of skipping ahead. So in this case, you can notice on the y-axis that they're going up by 50 every single time, okay? On your x-axis, they're only going up by 5, increments of 5 every time. When we actually construct your own scatter plots, you can use whatever measurements or increments of measurements that you would like on your graphs. Okay, whatever is going to be the most reasonable. So again, in this case, they decided to jump ahead to 300 and then go up by increments of 50. Or you can start it, go up by increments of 5. Whatever is going to make it a little easier for you. So I'm going to move myself back over to this side. I know it covers up just slightly a bit of the graph, but it's going to be a little easier for us to read some of these problems. All right, so problem number 1 asks, how many calories are in a sandwich that contains 17 grams of fat? So this whole entire part is my question. Now, here's the part they're looking for. We're looking for calories, and if it has 17 grams of fat. So what I'm going to do is I'm going to take a look at my graph here. Okay, I'm going to move myself over. Let's look at how a sandwich that should have 17 grams of fat, because that's the data I actually know. I want to know how many calories that is. So I'm going to take a look at my x-axis here, and I'm going to go find about 17, which looks to be about here, and I'm going to match it up with one of the dots that are given. Well, here's the dot that's given, so I can assume, based on the data that I have, that if a sandwich contains 17 grams of fat, it's going to have 400 calories, because this is where it matches up on the y. So right now, all we're doing is we're analyzing our data, okay? So I'm just going to abbreviate it as cal. It is a little hard for me to write on here, so sorry if it's a little messy. Bear with me. All right, let's go ahead and look at then this part. So how many grams of fat are in a sandwich that contains 600 calories? This time we're looking for the amount of fat. Okay, so I'm looking for fat. They give me that it's 600 calories. Again, my calories are measured on my y-axis. So I'm going to go ahead and look at my y-axis here. All right, here's the part where it's 600. And I'm going to move over until I find a dot that's on this 600 line. Oh, there's one right here. So how many grams of fat was that? That was 30 grams of fat. So I'll say 30 grams. And you can usually abbreviate your grams as G. Okay. Give me just a second. For some reason, my page isn't extending here. So I'm going to extend this. Hopefully it'll let me here. Switch to this. Just so it's easier for me to write in your answer. Oh, it does not want me to do it. All right, I might have to write our answer here above this one, but here's the last question down here. And I know it's hard to see. For some reason, it's not extending to the full page. Let me try and see if I can do something else. That's not going to do it. Not what I want. Not what I want. All right, we'll just kind of read through here. You should have the notes anyways. So the question is asking what tends to happen to the numbers of the calories as the number of grams of fat increases. So what is happening to the calories? What's happening to your calories as your fat increases? All right, well, let's take a look at your fat amount as it increases. Okay, what's happening to the amount of calories? So if I kind of look at this graph, for the most part, it looks to be that the graph's kind of going like that, or fairly close, okay? Think again back to when we were talking about all your other kind of graphs with lines, okay? In this case, this is showing me a positive slope, okay? It's going from left to right and it is increasing. I'm going up the hill. So what happens as the to the number of calories as the fat increases? The calories increase, okay? So I'm just going to abbreviate it as cal, and I'm just going to say increases. So as the fat goes up, so is the calories going up. Okay. Let's go ahead then and continue on. Again, if you want to pause this at any point, feel free to. If you have any questions, feel free to comment below, or you can comment on our Google Classroom. You can ask me on Remind. You can email me as well. As well as I'll try and do a check-in every single day with you guys. If you need to get on and check in with me, that would be awesome as well. Look for more details on that to come. All right, so this one isn't on your own. The question is, what if? Okay, so a sandwich has 650 calories. Based on the scatter plot in example 1, how many grams of fat would you expect the sandwich to have? So how many grams of fat would you expect the sandwich to have? Now, realize that it says based on the scatter plot. So that doesn't mean that there's necessarily going to be a data point that has 650 calories. This one, they want you to take an estimate. So make a good educated guess on how much fat you think is going to be in a sandwich that has 650 calories. Okay. Take a minute and pause the video. Go back and look at that graph. Okay. So I will again pull up this graph for a second. If you want to pause it at this point, you can. I will come back and I will explain the answer. Again, pause the video, check your work once I come back. Alrighty, welcome back. So if I'm taking a look at my data here and basing it on this graph, they said a calorie of 650. So kind of where I'm going to look is where is these dots going to kind of show up. Well, it looks to be that one showed up here, and it's very close to the 650. To be honest, my best educated guess would probably be right at this corner, which lines it up with 35 grams. Okay, so I would say 35 grams for this answer. Okay, so right now we are taking a lot of analyzing of these graphs and taking a look at the data firsthand. I'm going to say if you have an answer that's very similar to this, maybe you said 33, 34, 37, you are right on track. You've got the right answer, okay? Because it's a good educated guess. It's an estimate. If you said something like 15, I don't know if you really looked back at the graph, okay? So take a look at your materials, use what's given to you, follow those directions. Okay. All right. I'm actually going to pause the video right here. The videos only let me record about 15 minutes at a time, and I feel like this is a very good spot to pause the video. So please look for part 2 of this lesson. Go ahead and find part 2 and continue watching there. I'll see you in just a minute here at part 2.